Today's lesson is over section 3.7d, the last piece of rational functions that we'll talk about. And here we'll be actually kind of changing these into inequalities. And so kind of like what we did with polynomial inequalities, we'll do these graphing and we'll do them algebraically. Okay, so graphically, we'll kind of treat them just like we have been for these inequalities. So kind of ignore the greater than or equal to 0 portion of the inequality for right now. So I'm going to find my horizontal asymptote, which in this case, because the degrees are the same on the top and bottom, I divide the leading coefficients at the top and bottom to give me y equals 1. Vertical asymptote, set the denominator equal to 0, and gets me x equals -1. And then from there, I'm going to set the numerator equal to 0 to find the x-intercept if I have one, which in this case will be -3, 0. Then once I do that, I'll look for my y-intercept. So I'll plug in 0 for everything and for the x. And then I get 3, so I'll have a y-intercept of 0, 3. Okay. And then from there, just like we normally do, we'll graph everything. So I'll graph my horizontal asymptote at y equals 1. I'll graph my vertical asymptote at x equals -1. I'll plot my x and my y-intercepts. And then because those fit into two different parts, I'll graph. And then from here, now I need to be able to state what my inequality is or where my true statements are. So because visually I'm above the x-axis greater than or equal to 0, then it's everything from the x-axis or above. So that would be from -infinity to -3, and I can include that point since it's equal to. And then everything from -1 to infinity is true because it's all going to be above the x-axis because of that horizontal asymptote. So that would be my true statement. Okay. So here another example. So the top is smaller than the bottom in this one. So our horizontal asymptote is y equals 0. Vertical asymptote is x equals 2. X-intercept will be none because 8 does not equal 0. And then y-intercept, I'll plug that in, and I'll get -4 for a value. So it'll be 0, -4. Now I'll be able to graph. So I'll graph my horizontal asymptote at y equals 0. And then my vertical asymptote at x equals 2. And then my y-intercept of 0, -4. Okay. Here I'll need to kind of determine another value that will help me graph. So I'm going to pick 3 on the right side of x equals 2. And that gets me actually 8. So the point 3, 8 I'll be able to put on there. So then I can draw my graph. Now this case, it's everything that's less than 0. So that would be everything that's below the x-axis. So in this case, it would be from -infinity to 2. Okay. Notice that we're not including the asymptotes because we can't touch them. So it makes sense to be a parentheses there instead of a bracket. Okay. Now here we want to be able to solve algebraically. So sometimes you're going to have things on both sides. So before I can start, I need to move everything to either the left or the right. It doesn't really matter. And then I kind of want them to be one rational function on the left side. So that's why I'm making common denominators. So I give the 2 over x minus 1 and x plus 3 on top and bottom, the 3 over x plus 3 and x minus 1 top and bottom, and then I put them together, putting like terms together in the numerator. And then I get 5x plus 3 divided by x minus 1 times x plus 3. Okay. Now I can figure out my horizontal asymptote. So in this case, it'll be y equals 0 because the degree on the top is smaller than the bottom. Vertical asymptote, I set the denominator equals 0. So I'll get x equals 1 and x equals -3. For my x-intercept, I'll plug in, or I'll act like it's set equal to 0 and solve for the numerator. So 5x plus 3 equals 0. That'll get me -3/5. So then my x-intercept is -3/5, comma 0. And then I will plug in 0 for x in my new function. And so that'll get me 3 divided by, let's say, -3. So that'll give me -1. So I get a nice y-intercept of 0, -1. Okay, now here, instead of graphing, we're going to use a number line like we did in polynomials. And excuse my number line here, it does look a little confusing. You just need to have dots. I think previously I thought I needed the dashed lines, kind of like vertical asymptotes, but you really just need a dot to symbolize where your values or the key positions are. You can use an open circle if you'd like. Maybe that would be better. But we have one at 1, -3/5, and -3. So those are my like 3 kind of key points that divide up my area. So I'm going to need to pick values in each portion. So I'll pick a 2, -4, -2 in this case, and 0 will be my values that I choose. And I'll plug all those into my function that I've already kind of set up. And then kind of take a look at what I get. So plugging in 2. Now here, remember that I'm just looking for what they're going to equal, so if it's positive or negative, because that's what our inequality is trying to figure out, if they're above or below the x-axis. So I'm just going to put a plus sign above in the section. So for 2, I got 13/5, so it's positive. For 0, I already knew what that point was because it's our y-intercept. So it's -1, so it's negative. At x equals -2, I got a positive value, so put a plus. Then for -4, we'll get a negative value. So then we'll get a -17/5. So our answer for this example will be from -infinity to -3. We will have a parenthesis for the -3 because we're not including it because of the vertical asymptote. And then u from -3/5, which is a bracket, to 1, which is a parenthesis because it's also a vertical asymptote. Letter B, same idea. Now here I don't need to factor or anything because everything's on the same side already. So I can just go ahead and kind of figure out my key pieces. So hopefully you notice that like the beginning process of all this stuff is exactly the same as it has been for any of the 3 previous videos. We're still looking for horizontal slants, vertical asymptotes, x-intercepts, y-intercepts, all that good stuff, because we kind of need those key pieces to be able to determine our inequalities. There's just an extra step kind of at the end. So once I've plugged everything in, and then that gives me all my good stuff. So I'll make my number line here. Now here, I'm just going to use dots to represent those key places. So vertical asymptotes, x-intercepts, y-intercepts, whatever. And then in those areas, I'm going to pick 4 values because I'm like kind of broke up into four sections. So I'll pick -3. That gets me a negative value. So I'll write that it's negative on the number line. Excuse me. I'll plug in -1. And then that gets me a positive value. I'll plug in 1 here for the next section. That gets me another negative value. And then I'll plug in 4 here, and that gets me a positive value. Okay, now most of the time, well, probably most of the time it'll be kind of that alternating kind of thing, but sometimes it can kind of switch back based on if you have a double root or something, which is very unlikely, but it's very possible. So our answer is going to be from -2 to 0. I'm not including the 0 because it's not equal to, and then from 3 to infinity.